let's get us going. I'm probably going to skip a couple of these because we've done a lot, but we're just going to sort of get into it, make sure that we know and are comfortable with things. But if I find that we're repeating ourselves, I'm probably going to skip some questions. So don't panic if I skip a question. It's just because I feel like we've done it. All right, so I have said many, many times that there are two very important ways to represent relationships. One is through formulas or through equations, and the second is through graphs. Now, we had a look at some cool graphs in our last lesson. So those of you that are new, I definitely recommend you go look at that video because we had a look at some cool graphs and we started to draw graphs, which we're going to do again today. But those are two very important sort of foundation things that we need to know as we move up into grade 9, 10, 11, 12. So one of the ways that we can express relationships or describe relationships is through a formula. And we need to be able to both read what a formula is saying and understand what it's saying, but also write down formulas. So as a very quick reminder, there are two important variables that we work with. We work with an output, which is essentially our Y value. So the answer that we get once we performed all of these operations. And we have an input. The input is represented by X. And this is sort of the number that we use to perform the operations on. So if we go and have a look at our very first expression that we have here, we have got an description of a relationship. We have got the description that if we want to calculate an output number, so Y, 7 is subtracted from the input number, which we know is X, and that answer is multiplied by 5. So we want to essentially set up an equation that says Y is equal to, and we are then describing what we are doing to the input number in an algebraic expression or an algebraic equation. So let's do the first one together. We subtract 7 from the input number. So if I wanted to write an expression for that, I would say X minus 7. I'm subtracting 7 from the input. But then it says the answer, the answer of that subtraction is multiplied by 5. And so what's really important is that we take that whole difference and we multiply it by 5. Now, it is absolutely fine for you to write this with the 5 at the end. So Y is equal to bracket X minus 7, close bracket, times 5, means exactly the same thing. You are also more than welcome to simplify this. When I say simplify, I'm saying you are more than welcome to distribute the 5 into the bracket to get Y is equal to 5 times X is 5X, and 5 times negative 7 is negative 35. Any of those forms are absolutely fine in order to describe this expression. Obviously, this first blue one is sort of taking the words and directly putting it into an algebraic equation, but they all mean exactly the same thing. So whichever one you end up doing, it's correct. It means exactly the same as the other ones. Okay, so I want you to have a look at the second one. It's very similar to the first one, but I've added an operation. So I've said to calculate the output number, 7 is subtracted from the input number. That answer is multiplied by 5, and then 3 is added to this answer. So this is sort of like the very first one, but now I've added the 3 to the answer. So try and use your answer in question A to help you with question B. If and when you are ready, put your answer in the chat, or you can raise your hand and I'll get an equation from someone. Okay. Sasha, do you want to have a, oh gosh, okay. It's all fine. Right. Palesa, do you want to tell us? Oh, we've got both Palesas.
Ma'am, I said y equals in brackets x minus 5 close brackets 5 plus 3.
X minus 5, close brackets 5 plus 3.
Yes, ma'am.
Why 5 if we want to subtract 7?
Ma'am, isn't it they said the answer is multiplied by 5?
Yeah, so the
Ma'am,
answer,
no, ma'am, where you put 5, I said it's 7, ma'am.
see,
X
I don't
minus
listen.
7.
Thank you. Right, I wasn't listening properly. Well done. Right, so guys, that is exactly it. We've got the input number subtract 7, x minus 7. That answer times 5, so the bracket times 5, plus 3. Now again, you can write this with the 5 in front. So you could write this as y is equal to 5 times x minus 7 plus 3. Absolutely fine. Generally, we always try put the coefficient, so this number in front of the bracket, but honestly, it means exactly the same thing if it's at the back of the bracket. Really, yeah, like I say, it means exactly the same thing. If you wanted to, again, you can also distribute. So you can multiply the 5 into the bracket and you can simplify. So we know that this would give us y is equal to 5x minus 35, but now I have that plus 3. And we see that we've got like terms here. And so this simplifies to y is equal to 5x minus 32. But all three of these mean exactly the same thing. So when I say all three of these, I mean this expression, and this expression, they all mean the same thing. Okay, so any form of that is absolutely fine. They are exactly the same. So whatever you end up with is cool. Right, so please do take a screenshot so that you're not missing out anything. Pumazile, I see your hand. Do you have a question?
Evening, ma'am.
Hi.
Evening, ma'am. Would it be wrong to start with 5 plus 3 and then brackets x minus 7?
Okay, so when you say 5 plus 3, have you written it like this? Y equals 5 plus 3 and then the brackets?
Yes.
Okay, so what we need to be careful of is this is saying we're timesing it by 3, but we actually want to times it by 5. So what you could do if you wanted to is you could say y is equal to 3 plus 5 times the bracket x minus 7, because the order in which I add stuff doesn't matter, but the 5 has to be in front of the bracket because that's what we're multiplying by.
Okay, ma'am.
Okay, good. Right, Liesel, do you have a question? Liesel, which one? Okay, we can't hear you, so you might need to connect to the correct audio option, or you might just need to log out and log back in again so that we can get your audio working.
Yes, Lizelle. Hopefully you can hear us.
Hopefully. Okay, guys, so I'm assuming we've all taken screenshots. I am moving on swiftly. One of the other ways, and I've told you, please don't stress too much about flow diagrams. I'm just showing you so that you can get comfortable with performing these operations. One of the other ways that we can sort of express relationships is through a flow diagram. So I'm actually going to skip the first one, and I want us to have a look at the second two, mostly just because those numbers were very big and what's the point? Okay, so what we need to remember about a flow diagram is that we are taking our inputs, and I think of it like a number machine, and we're putting it into the flow diagram, and we're performing all of the operations that the block tells me to perform, and I'm getting my output, I'm getting my Y. So we can create a table for ourselves of our input and output values. And I've said before that this table structure is super, super helpful if we want to eventually draw a graph, and we're eventually going to use tables to draw graphs. Because remember, a graph consists of coordinates. which is an X and a Y. And so the table puts them in pairs for us so that we can plot the points. Right, so let's do the first one together, and then I'm going to get some hands to give me the rest of the answers. If we have a look at our very first input is a -2. So that's what I'm putting into my machine, and I want to perform these operations. So the first thing I need to do is say -2 minus another 3. Now, because we are already at -2 and I'm taking even more away, I know that I'm going to end up with a -5. Also, guys, when in doubt, use your calculator. I have no issues with a calculator. You're going to start using your calculator more and more, so by all means. I know some teachers don't allow you to. That's unfortunate, but I'm fine with you using a calculator here. Okay, so now we've got our -5. We now need to take that answer and times it by 2. So we need to take -5 and times it by a +2. Now we know a negative times a positive is a negative, and 5 times 2 is 10. So we get a -10. And finally, I take that answer and I add 1. So I take -10 and I add 1. And so I end up with a final output of -9. And so by taking my input and performing the operations, we're getting our corresponding output. Okay, so there are 4 more outputs that I want for the inputs 1, 0, 7, and 10. I'm going to give everyone like a minute or 2 to calculate those. And then you're welcome to either put them in the chat, or you can raise your hand to give me an answer. If you want, we can label this question A, B, C, D, and E, just so that if you're going to put your answers in the chat, you can label them and we know which answer is for which input. Okay. I know some schools do allow calculators, but I also know some don't. And so obviously you need to do what your school says that you need to do, but I have no problem with a calculator. Right, so try and find those outputs for me. I'm actually going to make this a bit bigger. I don't know why I've got it so small. And if and when you're ready, you can pop your answers in the chat, or you can raise your hand and try and give me those outputs. I already see some hands, but I'm going to give everyone another minute or 2.
You guys are doing really, really well. Let's go. Let's push.
Okay, we got lots of hands, so I'm going to go. If you haven't finished, don't stress. Get the answers as we go along. Pipedi, would you like to give us the first one?
Yes, ma'am.
Tell me.
It's gonna be -4.
Okay, walk me through it. So walk me through the operations.
I said what? I said I wrote the equation down.
Okay.
And after that, I said 1 minus 6 plus 1.
Okay, so remember, we're not timesing these numbers together. So we're not timesing the -3 and the 2. What I'm doing is I'm taking the 1, that is my input. I'm
Yes, ma'am.
minusing 3 from that, which gives me -2. And then I take that answer and I times it by +2, which gives me -4. And then I
Yes.
take that answer and I add 1. So what should it be? What's
didn't
minus
really.
4 plus 1?
What is -4 plus 1? -4 plus 1. It has to be negative. Wait.
Good, well done. -3. Excellent. Does that make sense?
No, man, because like I simplified I said 3 times 2 equals to 6. So I said 1 minus 6 plus 1.
Okay,
which
but like,
gave me 5.
okay, but like I say, remember, these operations have to be performed on the x. So if I wanted to, what I could do is I could write an equation for this. So this is saying that I'm subtracting 3 from x and then timesing that whole thing by 2, and then I'm adding 1 in order to get my y. So I could write an equation if I wanted to, but we're not taking these things and performing them on each other. I'm taking the x and then performing these operations.
Oh,
Okay.
yes, I understand now.
Okay, good. Right, so guys, we've got our B1, which is -3. Rebetswe, would you like to give us C?
Hi, ma'am. So, ma'am, I think C will be a +1.
Okay, walk me through it.
So, ma'am, I said 0 minus 3 is 0, and then 0 multiplied by 2 is still 0, and then 0 plus 1 is 1.
Okay, so I want to go back here. What is 0 minus 3? If I take 3 away from 0, what do I end up with?
You end up with 0.
Okay, so let's go this way. If I draw a number line, and here is my 0, 1, 2. And now if I'm sitting at 0 and I want to take 3 away, I'm subtracting. So I need to take 1 away, 2 away, 3 away. So what I actually end up with is -3.
Oh,
Okay, so what's -3 times +2?
ma'am, it's gonna be -6.
Good. And then what's -6 plus 1?
-5.
Fantastic. Well done.
Okay, ma'am.
Okay, excellent. Emmanuel, give us D.
Oh, evening, ma'am.
Hello.
Ma'am, so D will be 9.
Good. Walk us through it.
Okay, ma'am. So what I did is I said 7 minus 3 is 4
Mhm.
times 2 is 8 plus 1 is 9.
Perfect. So our output there is 9. Thank you, Emmanuel. Well done. Justin, give us our last one.
Hello, ma'am.
Hello.
So, so E is 15.
Good. Walk us through it.
It
Justin, you still there?
if you yes, ma'am.
Okay. So walk us through it.
How?
How you got the answer. So do the operations for us.
Okay. So I said 10 10 minus 3 is 7.
Good.
Yeah, and then 7 times 2 is 14
Yeah.
plus 1 is 15.
Perfect.
Yes.
Well done.
Thank you.
Okay, guys, so I'm hoping everyone who was a bit confused about the 15 was listening. It's 10 minus 3, which is 7, 7 times 2, which is 12, and 12 plus 1 gives us 15. So that's how we get our outputs over there. Very nicely done. I know there's still hands up. Do not stress. You will have an opportunity to give us more answers. So there are quite a few hands. If you have a question, please obviously leave your hand up. If you don't, please lower it. And like I say, there's definitely opportunity for you to give me some more answers, so don't worry. Okay, I hope I say your name correctly. You can correct me if I don't. Reneo, do you have a question?
No, ma'am.
No, okay. Right, so let us, just before I move on, I can see Theo's question on the chat of don't we start with multiplication? So Theo, not in the case of a flow diagram. In the case of a flow diagram, you need to do it in the order in which I give it to you. If it was like order of operations or BODMAS, like simplifying something, then yes. but a flow diagram, you do it in the order that I have given it to you. Okay, so guys, we're going to do this last one and then we'll hopefully get the answer to the brain break that we struggled with last week. So I'm going to let you try this one by yourselves because I do have faith that you can do it. Remember, we're going to take each of these x's, so the -3, -1, 0, 5, and 13, and we're going to then put it into our flow diagram in order to get our output, in order to get our y. So give it a go. If we're really struggling, I'll do the first one with us, but let's see how we go. Put your hand up when you've got an answer for me, or you can pop it in the chat. Let's again number these A, B, C, D, and E. You're doing exactly the same thing as what we did in the last question. Okay, so you take it and you perform those operations that I've given to you. I already see lots of hands. I'm going to give everyone another second or two. Oh, so many hands. Okay, Spiwe, would you like to give us the first one? Sorry, guys.
Yes, ma'am. And good evening.
Hello.
-3 plus 5 is equals to 2.
Good.
And then 2 divided by 2 gives us 1.
Good.
Then 1 minus 1 gives us 0.
Fantastic. Well done. Okay, I don't even think I need to explain that. We've got the explanation of how we got that answer. So our first output is indeed 0. Okay, Theo, do you want to give the second one a try? Sorry, I forgot where we were.
Yes, ma'am.
Okay.
It will be 1, ma'am.
Okay, walk us through it. So do the operations for us.
Minus 1 plus 5 is equals 4, ma'am. Then divided by 2 is equals to 2, and minus it by 1, then it equals to 1, ma'am.
Excellent. So our output here is 1. Right, Sasha, give us the third one.
Okay, I said 0 plus 5 is equal to 5.
Good.
5 divided by 2 is equal to 2, 5.
Good.
And 2, 5 minus 1 is equal to 1, 5.
Perfect. Well done. So guys, what's really important to take note of here is that decimals aren't a problem, or fractions aren't a problem. It is what it is. That's fine. As long as you've performed the operations correctly, that's cool. So Sasha gave us 1, 5. That is fine. If you want to write it as an improper fraction, I'll get my words out eventually, 3/2, or as a mixed number, 1.5. Personally, I like improper fractions. That's just a personal preference I have. I don't really like the others, but whatever. Any one of those three is absolutely fine. Now, just because it's a decimal doesn't stop us from being able to draw a graph. We know that 1.5 is halfway between 1 and 2. And so we would just plot our point there. So it doesn't stop us. It doesn't change the relationship. Just bear in mind, you can get decimals. Awesome, Sasha. Thank you very much. Tato, do you want to give us a fourth one?
Yes, ma'am.
Yes.
I said 5 plus 5 equals to 10.
Good.
And 10 divided by 2 equals to 5.
Good.
And 5 minus 1 equals to 4. And then 4.
Fantastic. So our output there is 4. Well done. Okay. Tracy, do you want to give us our last one?
Yes, ma'am.
Yes.
Number E is 8.
Okay, do you want to tell us how you got there?
Yes, ma'am. So, ma'am, I said 13 plus 5 equals to 18. 18 divided by 2 is 9. 9 minus 1 is 8.
Fantastic. Well done. Guys, your maths tonight is very much on point. Well done. Okay, so we have got all of our outputs here. What we can see, and this is sort of what we need to start seeing when we work with the relationship, is that as my X value is getting bigger, so as I went from -3 all the way up to 13, my Y values were also getting bigger. And so what that means is that it's an increasing relationship. We're going to draw graphs in a second, so you'll see what this looks like as a graph. But these are things to start noticing. If they're both increasing, well, my graph should look like it's increasing because that's the relationship it's representing. Okay, so let's take our brain break. What you guys hopefully will remember is that we got a bit stuck on this brain break last week. And oh, who gave us these answers? This is going to annoy me. Someone was very on top of it and gave us some values. So for those of you that are new, halfway through the lesson, we take a bit of a brain break because it's a lot to sit for an hour and do maths. And we want to still do maths, but do it in a fun way. Now, I forewarned you that this was going to be a hard brain break. So I'm glad we all found it hard. It's good to find things hard. It's good to struggle. It's the only way we figure out things. So we have so far gotten that, hang on, where we at? That 2 Santas is worth 22. 2 Christmas stockings is 14. And so 1 Christmas stocking is 7. So I'm going to give everyone a second or two to try and work out the rest of it. I need to get the answer now as well. And hopefully we can get the value of this final expression, which is the 2 Santas times 1 Christmas stocking times a snow globe. Please remember your operations and remember to think about how many there are. Justin, the joke, it's a bit of a pun. There's a fine line between a numerator and a denominator. Only a fraction of people will find this funny. This is because a numerator and a denominator form a fraction. We've got the numerator at the top. Okay, I'm not writing it out. We've got the denominator at the bottom. And there's a fine line separating them, or fine line between them. And so that is the maths joke, maths pun of the day. I feel like everyone's getting the same answer here, so I'm inclined to think this is the right answer. Let me just double check. Fantastic. Right, let me pick on someone. Tendo, do you want to tell us what the rest of these values are? Tendo, are you there? Oh, Theo, who's the winner? Let's see who wrote it down first. Winner was Unati. Unati was the first person to get the answer. Well done. Okay. Tabang, do you want to help us out here?
Ma'am, I'm not really sure about this answer, but I think for the last one, ma'am, is 10,078.
Okay.
Not 10,000, 1,000 and 1,078.
Okay, very, very close. What did you get for the value of the snow globe?
7, ma'am.
Okay, why did you get 7? Because 2 of these are 14, 1 is 7. So that takes us to 21. What do I still need to add to get 29?
Oh, so the value is it's 8, ma'am.
Good, well done. Okay, so now we actually have everything that we need. So this is 22 times 7 times 8. So Tabang, do you want to give us what the answer is?
1,232.
Fantastic. Well done.
Thank you.
Okay, nice guys. So that is indeed the answer, 1,232. Now, I fully acknowledge that that was a hard brain break. I suppose what we needed to do, and I'm really just telling you because you can definitely expect another tricky one like this because these are fun. If people on the chat, let's focus. What we need to do is, it's a little bit of like trial and error in this first step. You almost need to play around with numbers. And what is really important is that we know our operations. This multiplication part has to happen first. We know that we multiply first. So we need to figure out what two numbers we can multiply together so that when I add one of those numbers, I'm getting the correct value. Now, again, very much a very tricky one. I'll maybe try to be nicer next time. I was obviously in a bad mood when I decided to pick this one. But the operation that you're working with is super, super important. Obviously, what's also important is to figure out how many things you're working with. So here we only had one Christmas stocking versus two. And so we know that that impacts the value of those things. Alrighty, but really well done. I wish I could remember who gave us these answers. If you remember that it was you, please say so in the chat because you really helped everyone out. But there's our answer. Something fun. You don't have to stress about it. If you don't get it, that's cool. No problems. Just something fun to try. Alrighty. I hope we are all ready for the rest of our lesson. Justin and Kelebogile, I still see hands up. If you have a question, please leave your hand up. But if you don't, please lower it. And then we're going to carry on. Okay, Kelebogile, do you have a question for us? Whoops. Do you have a question? Okay. Justin, do you still have a question for us?
Yes, I do, ma'am. It's about the work, but then I'm gonna ask this question again, how I asked in geometry, nah. So
Okay.
and so like whenever in my whole life am I going to use graphs? Like when?
Okay, so when are you going to use graphs? Graphs are actually very useful, probably actually one of the more applicable things in real life. So one day, if you go into business or you own a business, you are going to draw graphs that represent your profits, represent your costs to company, etc., etc. All of these things come from graphs. There's a relationship and we can draw graphs. If you go into like a scientific field, the more complicated, I say the more complicated graphs, the graphs that have curves, those are often used more in a science field. So if we think about, like, often people say like the human population is growing exponentially. We drew an exponential graph last week. And so that tracks the growth of populations. There are other applications of that, like acceleration, and I suppose you can apply it to like microorganisms and their population growths, but graphs does actually have a real life application. So there you go.
Okay, thank you, ma'am.
Right. Guys, you got to remember I'm a teacher. And so I get these questions all the time. I have answers to them. And if I don't, I'll find an answer. Don't you stress. Okay, right. Let us come on and do the last little bit. Come on. My screen's just frozen. Let's see what's happening. Okay. Right, so let us go and draw some graphs. Now, we did a couple of these last week. No, we didn't. We did a couple of them on Monday. And this is sort of the stuff I really enjoy. I like being able to draw graphs. I like being able to see our input and output visually represented, but I also just am quite a visual learner. So I like being able to see the stuff. So what I've got here is a blank table for us. We're going to fill it in. But the first thing that we need to know is what is the relationship between our input and output. Now, sometimes I might give it to you in words. Sometimes I might give it to you in a formula or an equation. We're going to start with one in words. So we're going to put it into an equation and we're going to use it. You don't have to put it into an equation because I think everyone can multiply a value by 3 and add 1, but it is important to be able to write equations. So we're going to give it a bit of practice here. So it says the input value is multiplied by 3 and then 1 is added. So have a think. What would the equation look like? So y equals, what is that going to look like? Nkululeko, would you like to tell us?
Yes.
Yeah.
Evening, ma'am.
Hi.
So ma'am, the equation is gonna be y equals 3x plus 1.
Fantastic. Y equals 3x because the input is multiplied by 3 plus 1 because 1 is added. Well done. Thank you very much.
Yes, ma'am.
Okay, guys. So now we've got our equation. We now need to fill in this table. Now our input always goes at the top because this is our independent variable. We spoke very briefly about dependent and independent variables. And basically x can be anything. It's y that depends on x. I have to do stuff to x in order to get y. So y depends on x. Now, what is also really important to note is that you can pick any values for x. As long as you, excuse me, as long as you apply the specific rule that you're working with, it doesn't matter what your input is. You can decide. Now, because we're going to draw a graph, my advice is don't pick inputs like negative 1,000 or positive 275. You have to plot that on a set of axes. So don't go too crazy with your input values. Try and keep it relatively small. I would do some negatives and some positives just so that you can get a nice idea of the graph. But that's sort of just a general thing. Don't pick crazy input values when you want to draw a graph. I'm going to give you input values here. So we're going to go -2, -1, 0, 1, and 2. And I want you to go and determine those output values. So I just wanted to check. There are some hands already, and I'm going to assume that it is to answer this. I'm going to give everyone a chance. If your hand is up and you have a question, please just put it in the chat so that I know you are the person I need to unmute. Otherwise, we're going to give everyone a chance, and then I'm going to get some answers. Okay, while you're doing that, I just want to set up my axes because despite me saying on Monday I need to do this better, I didn't do it better.
We can do this, my babes. I believe in y'all. Let's do this. Calculations, calculations, calculations. Let's see. I see Tato, you are busy over there. That's the way to go.
Nice, guys. I see lots of hands. I'm going to finish my axes and then I'm going to take hands. Get in there. I'm getting there. You know, you would think I would learn, but obviously not. Okay. Ooh. Right. Let us see what we have going on here. Palesa Modise, do you want to give us the first one?
Ma'am, I got 2.
I suppose I also need to see the rule. How did you get 2? Can you walk us through the answer rather?
Ma'am, I said 3 multiplied by -2,
which gives
plus
you
1, 2.
What is 3 times -2?
Ma'am, it's 1.
Are you sure you're multiplying?
3
yeah
times -2.
Yeah.
Yes, ma'am.
Okay, so I'm a little bit worried. You might need to double check your calculator there. What is 3 times 2?
Ma'am, it's 6.
It's 6, right? So
yes,
a -2 times a +3 gives us -6.
Yes, ma'am.
Okay, and then -6 plus 1 gives us a -5. So that should be our output.
Oh, -6.
Yes.
Okay.
Okay, good. Right, Amiki, do you want to give us the next one?
Yes, ma'am. I got the answer as -2, ma'am.
Fantastic. Can you tell us how you got that?
So ma'am, I said 3, right ma'am, and then I put -1 in brackets, and then I got my answer as I got my answer as -3, and then I added it with 1,
Good.
which is -2.
Fantastic. Well done.
Yes, ma'am.
Excellent. Guys, you're on a roll tonight. Kakleho, would you like to give us the next one?
Yes, ma'am.
Yes.
Ma'am, at 0, I said 3 times 0 plus 1, and I got 1.
Perfect. Because what's 3 times 0?
3 times 0 is 0, ma'am.
Excellent. And so 0 plus 1 is 1.
1.
Okay. Lekona, would you like to give us the fourth one?
Okay, ma'am, I said 3 brackets and then I put 2 and then brackets and plus 1 and I got 7.
Okay, so it's fine. Lekona's done
Can
the
you hear me,
last one.
ma'am?
Yeah, I can. So Lekona's actually done the last one for us, which is fine. 3 times 2 is 6 plus 1 is 7. That's perfect. Sammy, do you want to give us then the output for 1?
Evening, ma'am.
Hi.
The answer would be 1 times 3 equals 3 plus 1 equals 4.
Fantastic. Okay, so guys, now we have got all of our we've got all of our outputs. And so what this means for us is that now we can draw a graph. Now you don't have to do this. I'm just going to do this so that we see what we're working with. Remember, because these are X and Y values, if we pair them up, what we have is a coordinate, and we know coordinates are X, Y. So if I list my coordinates, I've got -2, -5, -1, -2, 0, 1, 1, 4, and 2, 7. And so what I've got is X values and Y values that I can now plot on my Cartesian plane. Now remember, it's always X first and then Y. If I want to go and plot these points, I start with my X. So I'll start with a -2 for my first coordinate. So I go to -2 on my X, and then I go down to -5. And that's where I plot my first point. I'm going to label my points just so that you can see which point is which. You do not have to label your points. It becomes a little bit crowded, so it's not necessary. I'm just doing it so that we can see which points are which. Our next point is -1, -2. So we plot that, -1 on the X, -2 on the Y. And so I keep plotting my points. Now be careful, this one over here where it's 0, 1, it's 0 on the X. So I'm currently sitting there in the middle where the axes meet. And then I go up to 1 on the Y. So it's sitting on the Y axis at 0, 1. I then have 1, 4 and 2, 7. Now, if we sort of look at these points that we've drawn for ourselves, hopefully we see that if I were to start joining these points, what I'm actually probably going to get is a straight line. And this is one of the most important functions that we work with, straight line functions, or straight line graphs rather. So what we do is we take our ruler, very important that you use a ruler, and we join all of our dots like I've just done. We do put arrows on the end of our line to show that this line can continue to infinity. Obviously, we can't draw to infinity, but this relationship can keep going all the way to negative and positive infinity. And so what we've got here is our visual representation of this relationship. Now, if we go and have a look at this relationship, we can see that the X values were increasing. I was getting from a negative to more and more positive. And as the X values increased, the Y values increased as well. So what we have here is an increasing relationship. And this is exactly what the graph shows. My graph is going up from left to right. And so it is showing my increasing relationship. Okay, so being able to draw a graph is very important. And using a table to draw a graph is very helpful, because once you know what your equation is, you can very easily find your inputs and your outputs in order to draw a graph. Right, I do see quite a few hands, so I'm going to just ask that if you have a question, please leave your hand up, but if you don't have a question, please lower your hand, just that I know who does have trying to take a lid off a bottle that has no lid. Okay, Nonkululeko, do you have a question for us?
Yes, ma'am. Ma'am, is this graph called a linear graph?
Yes.
Because mine is a straight line.
Yes.
Okay, thank you, ma'am.
So guys, just on that, we can call them linear graphs. That's probably a much better word to use than straight line graphs. They are linear graphs, or you can call them straight line, but linear definitely. Matthew, do you have a question for us?
Sorry, ma'am. I forgot to put my hand down.
No problem. Okay. Oopsie. So that is sort of one example of our graphs. Now, I don't think we have enough time to do another example. So what I'm going to do is I'm just going to jump to what we were doing on Monday and just show you sort of some of the conversations we had. So we drew a lot of straight lines. Hopefully you guys have all of this. I'll go back to the notes now in case you need to take a screenshot. We drew lots of straight lines. We spoke about this whole increasing idea. We also spoke about a graph that decreases, and we noticed that if, I'm going to get there, that if the number in front of the x, so if this coefficient to x is negative, my graph is decreasing. It's representing a relationship that decreases. We also spoke about some cool functions. Now, you do not have to worry about these. We might ask you to draw these, but you don't need to know like their characteristics or their properties. Because a lot of people were asking, do we always draw straight lines? The answer is no. So we can get graphs that are curves. So this is called a parabola, and it's sort of like a cup shape. We notice that this happens when we get a squared on our x. And we also spoke about a graph that is exponential. And this goes back to Justin's question of when am I ever going to use graphs? This is the graph that could potentially represent a population's growth. So humans, yes, if you think about like rats, we always say rats and mice just reproduce all the time. They reproduce very quickly. So it's this like very sharp increase or exponential increase. And we can use this graph to represent that growth. Okay, so we did all of this on Monday. So the videos are online for those of you that are new. Everyone who was there on Monday, you have those notes. I'm going to jump back to the notes we were doing now, so that if you want to take a screenshot of this last one, you can. And I see Tabang's hand is up. Do you have a question for us, Tabang?
Yes, ma'am.
Yes.
Ma'am, I noticed that what you call that exponential one, ma'am. And Monday I forgot to ask you, ma'am, but like, I'm kind of struggling with that one. I don't really know how to do it properly.
So when you say you don't know how to do it properly, what do you mean?
Like finding the output answers.
Okay, perfect. I'll jump back there in a second. I'm hoping everyone's taken a screenshot. You will also see that Yolanda's posted the quiz link on the chat, which you can grab. If I quickly go back to this exponential, it is a tricky one to bung. So like, don't stress. And like I say, this is not something you have to do now. The reason I included it is because we have done exponents. Basically what you need to do is we take our input and we substitute it into the equation. So y equals 2 to the power x. So in place of x, I'm now going to substitute 2. And we know that 2 to the power 2 is saying that I'm multiplying 2 twice. And so that gives us 4. And so that is why my output there is 4. So it's all still just substitution. It is a little bit harder because it's an exponent. And like I said, don't stress about it. it was just something cool for you to see that we do get these other type of graphs. And this graph is probably one of the most useful graphs in the real world, if we can put it like that. Okay, guys, so I